So welcome to one-sided test. So previously we have seen an example about the two-sided hypothesis and how to test the hypothesis. Now let's look at one-sided hypothesis and how to check and examine our hypothesis. So to have a quick view, we have the two-sided hypothesis if the alternative hypothesis is not equal. For example, if we are testing for the mean, we have mu is not equal to mu naught for a specific value. So if the alternative hypothesis is larger than or less than, so it is said that we have one-sided hypothesis, and we will perform our test based on the one-sided hypothesis. So now let's have an example. We have the integrated circuit temperature. So our initial assumption or the null hypothesis that the temperature of operation will be 45 degrees centigrade. As we have seen before, our alternative hypothesis is indicating the values which we are worried or afraid to have. So we are afraid that the operation will evolve temperature larger than 45 degrees centigrade. So here we have mu is larger than 45 as the alternative hypothesis. So now we have a one-sided test. So as we have seen before, we have this population as a production line or a huge amount of ICs. So our methodology is to take a random sample at random time or random manner. So we have taken a sample with the sample size 12. So we have chosen 12 ICs randomly. And we have measured the property under interest, which is the temperature of operation. So these values are the temperature of operation for the different 12 ICs. And now we are responsible to check and examine if the temperature stayed at the acceptable value, which is 45 degree, or has exceeded the 45 degree boundary. So what are we going to do is to have some calculations. So firstly we have the calculate of the x bar, which is the sample mean. Simply we are going to sum all these values and divide by n, which is 12, to get the average or the sample mean. So the sample mean we have found that to be 45.86. We know the number of elements in our sample to be 12. We know sigma, because these, in our case, the sigma or the standard deviation or the variance or deviation is known. So we know that sigma is equal to 1. Also we'll use the confidence level of 95%, which is the most popular and common confidence level. If we use 95 confidence level, this means we have a value of alpha to be 5% or 0.05. So now let's continue. We have this now a standard normal distribution. So now we only have one side of rejection area. In the past or in the last example, we have the two-sided test. So we have divided alpha into right side and left side to be alpha over 2 and alpha over 2. But in our case, we have alpha or rejection area of 5% only in one side, which is the upper side of the normal distribution, because we have the alternative hypothesis as mu is larger than 45. So we have here the acceptance region to be 95%, which is the confidence level, 95%, all this white area. We have the rejection region or the rejection area, which is only 5%, and this region now is only one-sided to the right. We have the critical value here from the last example which is Z alpha. Now here we have Z alpha, not Z alpha over 2, because the area to the right of this point is 5%, which is completely alpha. So we have this point 1.645, which is Z alpha. So now our methodology is to compute the test statistic. So this is the same equation we have seen before. We have the sample mean minus the hypothesized mean over this is the population standard deviation divided by square root of n. So we have all these value. We compute the z0. We have seen that z0 equals 2.37. So now we have the critical value of z alpha to be 1.645, and we have z0 2.37. We see that, or we notice that z0 lies in the rejection area. So this is the critical value of z alpha. As I have said, here we have z alpha, not z alpha over 2, because this is one-sided test, and z alpha means the region to the right of this point equals alpha, which equals to 5%. So from the table of normal distribution, we find z alpha, we find it to be 1.645. So now we see that z0 lies in the rejection region. Because z0 is larger than z alpha, we will reject the null, or reject h0. In fact, what does it mean to reject h0? Rejecting h0 means that the average of temperature among the ICs is larger than 45, because the null hypothesis is 45 degree and we rejected the null. So we have rejected the null hypothesis. This means we have a temperature evolving from the IC during operation which is larger than 45 degrees centigrade. So this means we have improper or malfunction of the ICs, so we should take some actions such as redesign the integrated circuit. So we have tested our hypothesis using the Z0 or test statistic. Also we can use the confidence interval. So in this case we will have one-sided confidence interval. This is our standard normal distribution, as we have seen. To construct our confidence interval, we have the same criteria. We have probability that Z0 lies in this blue region, which is larger than Z alpha. So we have here we have alpha, and in the white region, which is the acceptance region, we have 1 minus alpha, which is, for example, 95%. We know that Z0 is x bar minus mu over sigma over square root of n. We can substitute by Z0 and rearrange the equations to get finally the confidence interval on the mean for the one-sided test in case of the alternative hypothesis was in mu larger than in mu naught. So this will be our confidence interval, which is only one-sided. So this is the lower limit, and mu goes from this lower limit until infinity. Now we will use the confidence interval to make the test of the same hypothesis. We have the value of Z0 2.37. We have the confidence interval. So now by substituting directly, so this is our result for the confidence interval. Our interval says that mu is larger than 45.208. So our criteria is to reject the null if the hypothesized mean is not included in the interval. So what is our hypothesized mean? It is 45. So does 45 lie here in this interval? In fact, no. So mu naught is not included in our confidence interval, so we will reject h naught, because as you see that here mu is larger than 45.2, so 45.0 is not included in this interval, and therefore we are going to reject the null hypothesis. So later also we are going to use the p-value to test our hypothesis. So now let's look how we can use the p-value to test the same example. We have seen that z0 equals 2.37. This is the blue area is the rejection region, which is 5%. So what is p-value? In fact, p-value is the area under the curve to the right from z0. So from z0 until positive infinity, the area under the curve will be the p-value. So from the normal distribution table, we can use the cumulative distribution function. We can conclude simply that the p-value is 1 minus phi of z0, because phi of z0 will give us the area under the curve from minus infinity until this red line, which is z0. So, but we don't need the area from minus infinity until to red line. We need from this red line or z0 until positive infinity. This is our p-value. So our p-value will be 1 minus the cumulative, or 1 minus phi of z0. So the p-value will be 0.009. So what are we going to do? We will reject h0 only and only if the p-value is less than alpha. This is a general rule for hypothesis testing. Either we are in two-sided or one-sided. So here we conclude that we will reject h0 when alpha is 0.05, because our p-value is much less than alpha. Here we will reject the null hypothesis. So finally, and our conclusion, either we use the test statistic or confidence interval or the p-value. Also for the one-sided test, we conclude the same result. Here we have rejected the null hypothesis, which means that the average of temperature during operation has changed to be larger than 45 degrees centigrade.